It was just another morning at work, September 30th, 1999, in a small building in Tokaimura, Japan. 3 men were mixing uranium, a simple but dangerous task. They were preparing fuel for a nuclear reactor, but they were doing it by hand, using stainless steel buckets, a shortcut, a fateful deviation from the rules. Hisashi Uchi, a 35-year-old technician, stood holding a funnel over a large steel tank. His colleague poured the last bucket of a uranium solution into it. In that instant, the universe revealed one of its most powerful and terrifying secrets. A brilliant, piercing blue flash erupted from the tank, a silent ethereal glow that bathed the room in an otherworldly light. This was not a chemical fire, it was something far more fundamental. They had unknowingly mixed too much uranium together, far exceeding the safe limit. They had reached a state known as criticality. They had created a self-sustaining nuclear chain reaction, a tiny, uncontrolled nuclear reactor right there in their room. The blue flash was the visible sign of an invisible storm of radiation, gamma rays, neutrons, blasting through their bodies, a cosmic bombardment on a terrestrial scale. For Hisashi Uchi, standing closest to the tank, that single, fleeting moment of blue light was the beginning of the end. He had just absorbed a dose of radiation so immense, so utterly beyond human tolerance, that it defied medical comprehension. The initial shock was followed by nausea and confusion. He soon lost consciousness. He had, in that fraction of a second, become the most radioactive man in recorded history. His body, the intricate biological machine that had been his home for 35 years, was now a battleground where the very laws of life were being systematically torn apart. The event itself was over in a flash. The chain reaction sputtered out as the solution heated and expanded, but the damage was done. The invisible particles had already completed their devastating work. They had passed through Uchi's body like a phantom hurricane, leaving a trail of molecular ruin in their wake. He was rushed to the hospital, his skin already reddening, his future erased. He was no longer just a man, he was a living laboratory, a tragic testament to the immense power locked within the atom, and the catastrophic consequences of unleashing it without profound respect and caution. What happened in that room was a criticality accident. It's a rare and dreaded event in the nuclear world. Think of it like a line of dominoes. In a nuclear chain reaction, a subatomic particle called a neutron strikes a uranium atom. The uranium atom splits. It releases energy and more neutrons. Those new neutrons strike other uranium atoms. Those atoms split and release even more neutrons. It's a cascading, self-perpetuating process. Under controlled conditions, inside a nuclear reactor, the chain reaction boils water to generate electricity. It's balanced, precise, contained, but in Tokamura, there were no control rods, no thick concrete shielding, just men, buckets, a steel tank. The prescribed mixing procedure was complex and designed to keep atoms far apart. It involved using a tall, thin dissolution tower, but JCO created an illegal, unapproved manual that told workers to mix in large open vats to save time. They traded safety for speed. When Uchi and his colleagues poured the 7th bucket of enriched uranium solution into the precipitation tank, they crossed a threshold. The mass and geometry reached a critical point. Atoms were close enough that neutrons from one split were likely to hit another. The dominoes fell all at once. The reaction went supercritical. To understand what happened to Hisashi Uchi, we have to journey deep inside his body. Deeper than skin, deeper than bone, past the organs, into the cells. Inside each cell we find the nucleus, the command center. Inside the nucleus, chromosomes. Chromosomes are exquisitely coiled strands of DNA, the blueprint of life. The double helix contains every instruction for building and running you. It tells your heart how to beat, it tells your lungs how to breathe, it tells your cells how to divide. It's the most complex information storage system we know. Imagine a storm of invisible bullets, gamma rays, neutrons. These are ionizing radiation. They have enough energy to knock electrons out of atoms. A high-energy particle zips through a cell. It doesn't just pass by, it crashes into the atoms of your vital molecules. Like a cosmic wrecking ball smashing a glass sculpture. The molecules are ionized. The molecules are broken. The molecules are transformed into highly reactive fragments. Free radicals. Free radicals are chemical vandals. They are unstable and steal electrons from nearby molecules. The most important target nearby is DNA. A radiation particle can hit DNA directly, snapping it in two. More often it hits a water molecule. Our bodies are mostly water. That creates a shower of free radicals that swarm the DNA. They chemically attack it, they break its rungs, they shatter its structure. The destruction we're talking about doesn't happen over hours, or minutes. It happens on a timescale almost too fast for us to imagine. It's a nanosecond blitzkrieg. A nanosecond is 1/1000th of a second. In the time it takes for light to travel just 1 foot, the initial devastating damage is already done. Gamma rays, neutrons, both moved at or near the speed of light from Tokamura. They pierced Hisashi Uchi's body and delivered their catastrophic energy in an instant. The battle for his life was lost before he even knew it had begun. Let's try to picture this speed. A blink of an eye takes about 100 milliseconds, that's 100 million nanoseconds. In a single nanosecond, so much can happen on an atomic scale. The high-energy particle arrives. It strikes an atom. It ejects an electron. This all happens in about a femtosecond, 1,000 times faster still. The ionized atom, the now free electron. Both can cause a cascade of further ionizations. Within a few nanoseconds, a single gamma ray can create a small cloud of thousands of free radicals along its path. Think of it as a subatomic lightning strike. You see the flash of light, but the electrical discharge that caused it is an almost instantaneous event. The radiation that flooded the room in Tokaimura was like a storm of these lightning strikes, occurring everywhere inside Uchi's body at once. Each particle forged a path of destruction, snapping the delicate strands of DNA. Some breaks might be single-stranded, the cell can sometimes repair those, but the high-energy neutrons in particular caused complex double-stranded breaks. Shattering the chromosomes into pieces, our cells have amazing DNA repair mechanisms, constantly patching up damage from sunlight and other environmental sources. They are the tireless maintenance crews of our molecular city, but they are equipped to handle routine wear and tear, not a full-scale demolition. The sheer density of the damage Uchi sustained was overwhelming. Imagine trying to glue a shattered glass back together when it has been pulverized into dust. To grasp the uniqueness of Hisashi Uchi's exposure, we need to talk about the numbers. Radiation dose is measured in units called sieverts, or SV for short. A sievert quantifies the biological effect of radiation on the human body. For context, the average person receives about 0.0024 sieverts per year from natural background sources, from the sun, from rocks, from the food we eat. Nuclear workers are typically limited to an annual dose of 0.05 sieverts. That's considered a safe, manageable limit over a working lifetime. The victims of the Chernobyl disaster, including the firefighters who bravely battled the reactor fire, received doses that were terrifyingly high. Many of those who died within the first month had received doses estimated to be in the range of 6 to 16 sieverts. A dose of around 5 sieverts delivered all at once is considered lethal for about 50% of people, even with medical treatment. It causes acute radiation syndrome, a complete collapse of the body's systems. Doses above 10 sieverts are considered universally fatal. The body simply cannot survive that level of cellular destruction. Now consider Hisashi Uchi. Standing just over 2 feet from the source of the criticality, he absorbed a dose estimated to be 17 sieverts. 17 sieverts. Let that number sink in. It is more than 7,000 times the average annual background dose. It is over 300 times the annual limit for a nuclear worker. It is potentially double the dose that killed the most exposed Chernobyl first responders. It was, and remains, the highest acute dose of radiation ever received by a human being who was then kept alive by modern medicine. This was, honestly, uncharted territory. No human had ever survived even for a short time after such a massive whole-body irradiation. The doctors who received him at the hospital were looking at a ghost. His white blood cell count, a key indicator of immune system health, had plummeted to nearly zero. His internal organs had been cooked by gamma rays. But most chillingly, when doctors later examined his cells under a microscope, they made a discovery that sent a shiver through the medical community. His chromosomes, the very structures that hold our DNA, were gone. In the hours and days following the exposure, Hisashi Uchi's body began to fall apart. This is the grim reality of acute radiation syndrome, or ARS. It's not just one illness, but a cascade of system failures caused by the body's inability to create new cells. The first systems to fail are those with the highest cell turnover, the immune system, the lining of the digestive tract, the skin. Faced with a patient whose biological blueprint had been effectively erased, the medical team embarked on a journey into the unknown. To restore his ability to generate new cells, they attempted a world-first procedure, a peripheral blood stem cell transplant. His sister was found to be a compatible donor. The hope was that her healthy stem cells would find their way to his bone marrow and begin producing new, healthy blood cells. The transplant was a partial success, a flicker of hope. The new cells began to graft and produce new blood. For a moment, it seemed like a miracle, but the radiation had created a hostile environment. The transplanted cells were also being affected. It was like planting seeds in poisoned soil. The doctors threw every tool in the medical arsenal at him. Dozens of blood transfusions, massive amounts of fluids, experimental skin grafts. He was kept alive on complex life support that managed his breathing, his heart, his failing organs. The ordeal lasted 83 days. 83 days of unimaginable suffering and relentless medical effort. Machines and the sheer will of the team kept him alive. On day 59, his heart stopped. The team revived him, but it caused further brain and organ damage. Finally, on December 21, 1999, after multiple organ failures, his heart stopped for the last time. The most scientifically stunning discovery came when doctors performed a chromosome analysis. His chromosomes were not just damaged, they were annihilated. The image of his karyotype is one of the most haunting in modern medical history. It was not the blueprint of a human being. For science and medicine, his 83 days provided a grim but invaluable data set. The knowledge gained has informed emergency protocols worldwide. His tragedy has made the world safer for those who work with nuclear materials. The Tokamura accident was a wake-up call about safety culture. Not technical failure but human error and systemic negligence. The story of Hisashi Uchi is a profound lesson written in the suffering of one man and the tireless efforts of those who tried to save him. It reminds us that the same nuclear processes that power the stars and create the elements necessary for life can, when mishandled, unleash unimaginable destruction. The energy locked within the atom is a cosmic fire, one that can warm our world or consume it. A lesson from the cosmos delivered to a small room in Japan about the power of the universe and our responsibility to wield it with wisdom.